If you apply log to both sides, common log, you could also apply log base 2 to both sides, and it would work out well as well, had you done that. And then once again, you can take the exponent and write it as a coefficient. And then you can divide both sides by log base, or by log of 2. Your calculator should give you approximately 3.81. So that one we do not write in interval notation because it's not an interval. Questions? Yep. Number 6, if you just simply use the change of base rule, you get common log of 7 divided by common log of 5. Put that in your calculator, and you're going to get 1.21. You only need interval notation if it's a less than or a greater than problem. Number 7. This one's a little crazy. On the right side we have a radical. Radicals don't work well with logarithms. So let's change the radical so that it's an exponent. Square root means to the 1/2 power. Now we have a power to a power, so if we use the power to a power rule, it says you can multiply the exponents. So we have a 1/2 times x is 1/2 x, or x over 2, and then a 1/2 of 2 is 1. So it simplifies to that. Then if you want to get rid of your exponents, if you log both sides, the point of doing that, it enables you to take your exponents and put them as coefficients. Notice this problem is going to be a little more complicated than the previous ones because there's x's on both sides of the equation. Notice the right exponent is more than one term, so you need to put it in parentheses. The best way to finish this would be to use the distributive property, multiply log of 3 times both of these things in the parentheses. It's going to give us x divided by 2 log of 3 minus 1 times log of 3, which is going to be minus log of 3. Now we have some terms on a term on the left that has an x in it, and we have a term on the right that has an x in it. We want to get those terms on the same side of the equation so we can factor an x out. So I'm going to subtract this term from both sides of the equation. So I have x log of 2 minus x over 2 log of 3 is greater than negative log of 3. Now once again, both terms on the left have an x in them. I'm going to factor that x out to the front. So we're going to have x times common log of 2 minus 1/2 common log of 3. And that's greater than negative log of 3. Simply have to get that purple x by itself now. Right now it's being multiplied by that monster in parentheses. Divide both sides by the monster. And the x is greater than negative log of 3 divided by log of 2 minus 1/2 log of 3. And that can be put in your calculator. You should get x is greater than negative 7.64. In interval notation, parentheses, negative 7.64, comma, infinity. When you use your parentheses for this, you should have parentheses in the following places. On both sides of the 3. Your entire denominator needs a set of parentheses. Parentheses before and after the 2, and before and after the 3 here as well. You don't. You can. It's not hurtful if you do, but you don't need it. If you're not getting negative 7.64, please tell me so I can be of assistance. Yes, sir? Your entire denominator needs to be in parentheses. See the red parentheses up there? That's because there's more than one term. In the previous ones, there was only one term. Anybody else having problems? Just got to check to make sure inequality is in the right direction. Because when you log both sides and you're doing all this crazy stuff, sometimes a negative gets slipped in there and you can't see it. So take the original, get 0 by itself. So we're going to have 2 to the x minus the square root of 3 to the x minus 2 is greater than 0. On a number line, put the solution that we got. We're going to use a dashed segment because this was just greater than. Probably going to use a calculator for this to see what these test points do. I'm going to put in a negative 10 on the left and a 0 on the right. I'm not going to take the time to do this, but if you were to put those into your calculator, into that equation, that inequality I should say, you will find that you get negatives on your left and positives on your right. So it's to be greater than 0, which confirms that the answer that we had down here was correct all along. It's always good to check though, because sometimes it's the wrong direction. Questions? We're going to skip number 8. Number 9, this one is a little bit crazy, just a little bit. If you would use the change of base rule, get common log of 9 divided by common log of x is greater than 3. If you were to then multiply both sides by log of x, which I would assume would be your first natural instinct, which would be a great thing to do, and then divide both sides by 3, because you're trying to get x by itself, and then how do you get rid of the log on the right? Because if we got rid of it, we'd have x by itself. Anti-log both sides, which means 10 to the exponent of this. So if we anti-log both sides, gets us x by itself. Just a reminder, this means 10 to this exponent. If you put that into your calculator, you're going to get about 2.08. Nothing crazy has happened yet. There's a couple crazy things that we got to watch out for. On your number line, you're supposed to put your solutions, but you're also supposed to put things that can't be your solution. None of the other problems applied to that. If you remember right here, your denominator can never equal 0. And if you look in this spot here, since there's a variable in your denominator, that could be equal to 0. So we have to make sure that common log of x doesn't equal 0. Then you're dividing by 0. If you change this to exponential form, we're saying 10 to the 0 can't be x. 10 to the 0 is 1. So for this problem, we're saying our solution is 2.08 and everything bigger, but it can't be 1, which fortunately for us, 1 doesn't fit in the 2.08 and bigger. Another thing you have to check for is this right down here. Your base has to be positive. Our base here was x. So we have to make sure, because of that, that our base is always bigger than 0. So if everything worked out well, if we solve this correctly, I guess I said that wrong. This is saying x is less than 2.08. Let's take our solution and our things that it can't be and put them on the same number line. In order from left to right. So we have a 0 on here. We have a 1 on here. We have a 2.08. These are all dashed because the original problem just said greater than. If you take the log base x of 9 is greater than 3, and you get 0 by itself, I'm going to use the change of base rule, so it's log base 10 of 9 divided by log base 10 of x minus 3 is greater than 0. If you pick test points for this, something to the left of 0 like -1, between 0 and 1 like a half, between 1 and 2.08 such as 2, to the right of 2.08 such as 3. If you were to put these things in your calculator, you would get the following. You would get undefined, you would get a minus, you would get a plus, and you would get a minus. The answers are our pluses because it says is greater than 0. So our answer is different than what we originally thought. Our answer is bigger than 1 and less than 2.08. If you solve it for 0 and graph it, then this number here won't show up. That's why. So our answer for this, our answers are starting at 1 and going to 2.08. Does not include either of those numbers because it's a greater than, there's no equal to. That's as crazy as it gets right there.